Hello, everyone. This is Arnava Majumdar. We have the Western Sydney University team here with us today. Let me introduce them to you. It's Michael Colligan, Wesley Tang, and Hafiz Shafruddin. I hope I can pronounce the names properly. Please excuse me if I didn't. So they had been working with us on this CTN project, Cognitive Telescope Network API hardening, for quite some time now. I forget how many weeks it is. It's probably more than 10 weeks, right?
Just around 10 weeks, yeah.
Just around 10 weeks. Okay, great. Thanks for that, Michael. So we'd made a lot of progress. The first iteration of this project for the APIs was done by NC State. Let me switch over and show you that team as well. So this is a team from NC State who started with the API, and within the first iteration, Sam, Chandler, Thomas, and Devin could get to the APIs. We couldn't get to the error handling properly, and we could not get to the containerization as well. So this team was tasked with that specific job, and they did a great job in containerizing it and hardening the API. And I would also like to thank the other mentors, Ron Lin and Professor Anupama Ginge, who couldn't be with us today. But I would like to extend my thanks to both of them for making this project possible. So having said that, I'm going to hand you over the presentation, Michael, and you can start the share.
Perfect. Let me just find the button. Share screens. Can we share screens at the same time?
No, you can grab the share from me.
Oh.
Or I can stop the share if you're having any difficulty.
Yeah. Oh, there we go. Now I can.
Yeah, how about now?
Yep, perfect. All right. Well, just to reintroduce us, I'm Michael. I'll be going over just the overview of the entire project as a whole, and then Hafiz will be going through the specifics and just the demo of it, and Wesley will go through the API development and finish this entire project off. We've been working with IBM, especially Ron, who's been a fantastic sponsor with us so far. So, yeah, let's get right into it. So firstly, just some background on what exactly the Cognitive Telescope is. Transient events are astronomical events that can happen in mere seconds to years. They often can contain scientifically significant data, so collecting as much as we can is critical. So this can either be done by powerful telescopes to observe the events as quickly as possible, or coordinating as many telescopes as we can to maintain a continuous view. However, this can be hard since individual telescopes cannot often catch these fast events. So the network's goal is to collect as much data as we can and organize as much collective telescope power as we can to catch these transient events as quickly as possible. So all the data can be categorized and observed and passed through the astronomical community as a whole. So the CTN is a multi-year IBM project spanning multiple teams. The authentication API, just like Ron has said, has already been developed, but no fault tolerance has been implemented. So our focus for the last 10 weeks has been working with Ron to enhance the existing authentication API. We've had a relatively straightforward goal of integrating enterprise exception handling specifications to log relevant error handling information to a dedicated database. This also making sure that all components were independently containerized so they can be easily deployed for future Kubernetes clusters on IBM Cloud servers. So a quick and simple overview of what exactly EEH is. It's a system of standardizing the structure of exceptions so that the application can be the logs can be in a common format, so each event can be logged to a centralized database easily. So it can be analyzed later, so any events that the system may occur can be looked at in one specific database, and later on a UI team will gather the information and be able to process for relevant issues that may occur in the system. So the overall system that we've built so far has been broken down to these individual aspects in their own distinct Docker containers. IBM Connect is used for the API gateway, which is connected to the user authentication microservice, which has already been built by the previous team. Everything has been Dockerized in their own containers and connected properly. We've built a MQ database for the user data authentication. Any runtime exceptions from the user authentication API sends its logs remotely to an open IBM Q channel, which is in the same Docker container as the EH daemon, which processes the error logs on the opposite side of the channel. So these process logs are then sent to a separate IBM DB2 container, which is currently posted on Bluemix servers. Well, hopefully. All these future containers will be installed to Kubernetes clusters on IBM Cloud servers. However, we couldn't get the credentials to upload to the servers in time, so a VM was given to us by Ron just to demo the system as for now. But EH was implemented into the authentication API, so it sends proper errors to MQ server when we need to. We've also developed scripts to package all the required files on Box, which with installation development guides to streamline the entire process for future teams. And yeah, how do I exit out of this? So we've split it off into distinct containers, including the installation manual and every single script you may need. I'll hand it now over to Hafiz so he can go through the details and demo the system just briefly. How do I bring it over to you, Hafiz?
You can stop the share, Michael, and then Hafiz, you can grab it.
Okay.
Right. So we go to the detail of the solution itself. So what we've done is we have the XML definition defined in. So of all the exceptions, we have the name of the exception itself, the privacy number, the code number, description, as well as all the parameters required for the specific exception. And using this XML file, we have the utility called excutil that can generate a Java class. So this utility will generate all the static classes, which is, you can see the screenshot at the bottom right. And this will return the catalog exception type. Right. So in the API itself, we need to do two things to set up. First is the setup of the catalog itself. So it will get the catalog information from the generated Java class from the exception utility. And the second one is to set up the message queue itself. So in this message queue name, we give it a name, the queue name, as well as the IP address of the queue server. Next, the second thing that we did in the API is to parameterize database credentials. So to make it easy for migrate the database to something else, because right now we have the Docker container within the same VM. So in the future, if you want to move the database to somewhere else, for example, Docker Compose, then it can be done easily through the Docker configuration. Right. Going into the overall system architecture. On the left side, we have the XML definition that we have to find. So in our Ctn XML file, there are two things being done. First is the generation of the Java class, which is going to be used by the API. And the second one is...
Yeah, please, sorry to interrupt. Can you make it larger, like put it in the presentation mode?
Yeah. Let's try F11.
Oh, you're running it from some other drive, right? OneDrive or something, which is fine. Yeah, if he, yeah, from the current slide should do it, right? The second button on the top.
Yeah.
See if this works first. Right, perfect.
There we go. Thank you.
Yeah. Right. So the second thing it needs to do is to import a schema to the DB2 database. So the XML file is used to import the schema for all the relevant tables. Next, in the API itself, we use the try-catch error block to capture any runtime exceptions. So all of the exceptions will be sent to the message queue using the send exception method. This is captured by the message queue, and the daemon will send all the XML output into the database. Next, we go to the microservices. We have 4 Docker containers, all communicate with using ports. From the host itself, we have the API that output all the XML output to port number 1414. And this listens, the message queue listens to this port, hands it over to the AH daemon, and sends it to database using the port number 50,000. For the API itself, the database credentials or the authorization is stored into a another Docker container through the port 3306. To secure the API, it is secured by the API Connect using external. And to view the database, it can be viewed by the UI team on a separate computer. Right. So I'll hand this over to Wesley.
Leslie? This is just to give a quick overview before we show off the system. If Wesley's mic is there.
Sorry, I was muted. Can you see my screen?
Stop sharing if you can, Hafiz.
So which screen is this? Is that you, Hafiz?
I know. It's Wesley's.
You should be able to see.
Mm-hmm.
All right. Well,
okay.
Where am I? Yep. So, with the view. All right, so basically in the API-C, we can open the API in the API manager, and you can run the tests through the API manager. As shown, operation login. Currently, the OAuth isn't working. All the definitions are in the the YAML or the Swagger file, but it hasn't been tested against the actual login server, the authorization servers. You can use the assembly to test it and try to access the what was the name of the oh, that's weird. There we go. Yeah, you can use it to log into the server or the VM. Unfortunately, the dev portal does not you can't test it through the dev portal, as the dev portal works on HTTPS, but the VM currently only runs on HTTP. Hopefully, when it's deployed on the Kubernetes server, that'll be on HTTPS, and that'll mitigate the problem. But for now, you can view it on the dev portal, but you cannot call an operation or test it.
Hey, well,
yep.
that's just since we're using the VM just as a demo for now,
yep.
Whenever future teams can deploy it to Kubernetes cluster, that'll be where API-C can be fully implemented. But for now, we'll just go through a demo of exactly how the entire system functions. So if you can show screen back to mine, Leslie. I'll just go through the implementation for how it's actually put into the existing API. So integrating EH into the existing API was relatively simple. It's just making sure it catches every single possible error that it can occur within the system. So every single exception that can be thrown gets caught. It passes through a generic function and just make sure it gives the relevant data towards it. We created our own API exception. So it categorizes any single type of error that can occur, makes sure it looks through all the different types and outputs the correct format, and then sends it off to the connected MQ channel, which is up here. All variables are externalized for when it gets deployed onto before it gets deployed into an image for the Docker container. But implementing it was relatively simple, but we'll go through a demo on Hifiz's system, which managed to put on the VM, so we can test it out for you guys right now. We also made a quick UI demo just to show the output, since the UI team could not get in contact with over the last 10 weeks. Hafiz, do you have that running?
Yeah, I do.
Okay, let me close this. So any exceptions that get thrown, for example, wrong parameters for the database, or the database spitting out errors, or not even running at all, or anything that goes wrong internally into the system gets caught and logged into the MQ channel. And right now we have it all running on the VM. So just show us through some examples of it catching.
So right now we have the Docker running, and let me just check the Docker.
Yeah, just a little clarification. So what you guys have running is on a VM on the IBM Cloud, and you have all the 4 Docker containers running on a single VM for the time being, right? When we fully implement it later on, like you guys were saying, we're going to deploy these Docker containers onto Kubernetes, which will run on multiple worker nodes or whatnot, right? So depending upon how the workload will be. But right now, we are running all these 4 Docker containers in a single VM just for testing purposes and development, right? So yeah, with that clarification, just take it over.
To note as well, we've also developed all the scripts and files needed for any future teams to easily deploy it as a dev environment or just straight installation. We've made guides for every step you need as well. This is also just a demo UI just to show just the output of the database, so we don't have to make it look so messy.
Yeah. Right. So now we have all the 4 containers running. This is the API, the MySQL, EHSQ, and EHDB. So let's test this. We try to refresh this. Right. So if you click submit with the correct email address and password, you will get a session token. Right. So to trigger a runtime exception, I will try to stop the MySQL database. This is it in short file, and it's edited. So let's try this again. If you click submit, oh sorry, the wrong address. Yeah. So right. So if you click submit, let me refresh this. Click submit. Yeah. So now it says an error occurred accessing the database. This comes from the API. and you can actually see the exception here. Okay, this one, the second line. You can view the call flag here. And to show that it works again, I can restart the database. And once done, go back, try and access the API and get the session token. Yeah. Okay, so back to you, Michael?
Yeah. I just want to show a couple more things as well. Just let me share my screen.
Sure.
As of right now, we're still running into an issue with EUH, just categorizing the, logging the actual exceptions into the database, but that should be fixed at a later date. As of right now, the API has its own JUnit tests to make sure everything is operational. They spit out their own mock exceptions, so running this as JUnit tests will allow us to test the whole range of SQL errors if it does happen. If my Eclipse does not explode. Some time. Well, before there we go. Well, it's running through them now, but this is what the output looks like towards the database. There should only be one entry per exception, but right now just because the EH is running into some issues, it spits out two. But the dump, all the XML information still gets captured and stored as into the database. So each SQL error, most errors are either null or SQL errors. They're still catches any type that can occur, but it's hard to forcefully throw Java exceptions. So during just mock exceptions, we can see that it does capture the right error message, what occurred during the error, and all the relevant information. Right now it's just mock, so we can't really throw any useful SQL states, but yeah, everything gets caught, put into this database for any future UI team. Right now we're just running the mock UI just for demonstration purposes, but as long as everyone follows the guide, this can be set up easily. And other than that, that's pretty much it. Handles everything we needed to. For API-C, I'll hand it to Wesley just to finish it off.
Yeah, before we get there, some clarifications. The EH errors that we were noticing, right? So that got introduced as a bug in a later release, which is being integrated right now. So that needs to be fixed, like you mentioned, Michael. That got introduced because of the event integration and the pluggable event integration into it. So that's something for the future team to look into, or maybe it's going to get fixed before that. And we're going to rebuild this. Okay. But the good point is all the data is getting stored into the database, and it's been generated. So essentially what you simulated was a connection error in the database because phase you shut down the database, right?
Yeah.
You killed that container, right? So yeah, so that's what it kind of simulated, and it is being stored. So So that's good. Once we fix the bug, we'll get some more detailed information into it. Okay. So that's all I had as clarifications over there. So let's go on to Wesley. Your microphone is muted.
So yeah, I pretty much showed you everything I could with API-C. We've got the basic API up, and you can get a basic test going, and what I said about the dev portal. So in conclusion, sorry.
Well, just moving forward, I guess, if that's it from API-C, just further improvements with, well, we need to integrate with the UI team for future development, because right now we're essentially just logging it to the database. So most likely additional endpoints will be needed for the API for retrieving data to another microservice. Accessing to the VM requires HTTPS, but won't be an issue once it's actually deployed to Kubernetes clusters. So that will need to be implemented before API-C can fully be used. And obviously deploying to Bluemix and Kubernetes will be the next step towards this project goal. But yeah, those two issues are the biggest we need to face for a later date.
Okay, excellent. So thanks, Michael, for clarifying that. Do put that as a note for the future teams to take over. And this is not the end of this session. We have other APIs we integrated into it. One of the APIs, for instance, was developed for communication with the telescope itself. That was a separate team. It's a separate discussion altogether, but they created a simple API plus an IoT integration from the API to be able to handle the telescope. That just went through the first iteration, so we're likely to start the second iteration in fall with NC State plus some students and professors from Illinois Institute of Technology is going to join in as well into the effort. So we'll get that module ready to actually connect to physical telescopes. Very exciting. And that API also needs to be integrated into this basic API that we have for login and authentication and all that. But this is going to be the gatekeeper of all APIs, because it controls the login as well as validates whether it's a valid session or not. And then we move on to the other APIs. So in essence, this is essential. It's going to be integrated with other APIs for the cognitive telescope network project. And these are things for the future to be looked into. Okay, so having said that, I would like to thank you all for getting this all together in a very successful manner. Thanks, Michael, Hafiz, and Wesley for bearing with me for the last 10 months. 10 weeks. And thanks to Ron, Lynn, and your professors to help you along with the project, especially Professor Anupama Ginjik. So thank you all for this. Any final comments from the team before we end the call?
It's been our pleasure.
It's been.
Okay, thank you guys. I'm going to. Go ahead, Michael.
Real quick, for any future teams, we'll make sure everything is documented within the what we submit in the box. So any details we miss or clarification, just go through the guides. We'll make sure we put anything we can.
Absolutely. So just put any clarifications that are needed, put it into our box folder structure, and future teams will take it up from there, like this team took over from the NC State development, right? And last but not the least, I'm going to after we close this project down, I'm going to send you your badges, well-earned badges, and do pay attention to your email and LinkedIn, and accept those badges, right? Like I mentioned before. Okay. So thank you, everyone, for this wonderful project, and I'll end the call for today. Okay. Thank you.
That's it. It's been a fun 10 weeks.
Hey.
Okay, thanks, guys.
All right.
See ya.
Thank you very much.
Thank you very much. Bye.